This conference will now be recorded.
Hello, everybody. Welcome to the Satellite Book Club Seminar Series. This is session number 33. I'm Jordan Girth with the National Weather Service Office of Observations. Thank you for joining us today. I hope you're staying well and having a good month of January. We got a great presentation today from Nick Lanelieb, the Science and Operations Officer at the Weather Forecast Office in Marquette, Michigan. Our facilitator is Karen Eagle, a newly promoted lead forecaster at the Weather Forecast Office in Duluth, Minnesota. The title of the presentation is GOES-R Ice Product Evaluation and Potential Applications to Lakeshore Flooding. Just a few reminders before we get started is that this session, as always, is being recorded, so feel free to refer your colleagues to the recording on the VLab if they're not able to join us today. There'll be an opportunity for Q&A after the presentation. Please feel free to enter your questions in the chat room, and that will help us field them in the order they were received. If you're willing to be a future presenter, have an idea for a talk that might be applicable to the Satellite Book Club and our broadening audience, please get in touch with us. We'd love to have you. And the training team can help create training materials that may be unavailable or help you find materials that you may be unaware exist. Brian Mata and his team at the Office of the Chief Learning Officer can field your questions regarding that. Thank yous are in order to our TOWR-S team, particularly Kashad Bowman, who's organizing the Satellite Book Club, as well as the Office of the Chief Learning Officer and the GOES-R and JPSS programs. Without further ado, I'd like to introduce Nick Lanelieb, who joined the Weather Service in 2009 as a SCEP student for the ROC Applications Branch, where he worked with scientists evaluating radar data and algorithms, including the new dual pole products. In 2010, he took a meteorologist position at the Great Falls, Montana Forecast Office and progressed into the ITO in 2014. Then in the fall of 2019, he moved to the SUP position at the WFO in Marquette, and happy to be in the Great Lakes as part of the team there. Nick, looking forward to your presentation today. Thank you so much for being with us.
Thank you for having me, and I just want to say congrats to Karen too. So I just met her virtually yesterday preparing for this meeting, and we'll be neighbors pretty soon.
Thank you.
And so I'll get started here. So what I wanted to talk about today was this ice product evaluation that we've been doing. Our office, Marquette and Duluth, have both been part of this ice product evaluation. It actually started last year, but this is the first year really kind of heavily diving into things for me. And so we'll talk a little bit about you know, an overview of that evaluation, the ice products that we're getting, and a little bit of, you know, what goes into making those products, and then potential uses. So as we're going through, you know, evaluating these products, we're thinking, well, you know, where can these apply? And lakeshore flooding is a big deal here right now, and ice can help. So this presentation probably has more questions than answers. So as far as the products that in this evaluation, so right now they're in that experimental stage. They haven't had a lot of exposure to operational meteorology, but been working with the TOWR-S team, Lee Byerl and Kashad Bowman, both looking, you know, evaluating these products and learning more about them as we go here. And doing ice evaluation is a little tough when you're off to a really slow start. So it's been relatively warm, and here's a plot from Coastal Watch, and you can see the long-term ice average is typically, we're starting to get near 20% this time of year, and we really have very little, you know, if any, ice out there on Lake Superior. And a little bit about the product. So there is, we're seeing ice concentration, temperature, thickness, motion, age. The two I'm really gonna focus on here is the concentration and temperature. And of course, have these products from the polar orbiter as well, but kind of seeing, could goes with the higher temporal resolution. What could we learn from that as well? And so ice concentration, how it's made. Well, with the polar orbiters, you have the microwave sensors, so you're able to see the ice through the weather most of the time. But with the GOES-R, we are using that ABI, so it requires clear skies in order to detect the ice. And if we do meet those clear sky conditions, then it moves on to doing either daytime or a nighttime check. And during the day, it's going to use the near IR bands, the 0.86 micron and the 0.61 micron, and calculates it in this normalized difference snow index. And if that's above a certain threshold, then it'll count that pixel as part of the ice mask. And then from there, it does one more check and makes sure that the surface temperature is less than 275 K, which is I think like 35.3 Fahrenheit, somewhere around there. And basically what that's doing is accounting for, well, you could have melted water on top of the ice. And the reason this works really well is because snow-covered ice has a high reflectance in the visible channel, but a pretty low reflectance in the shortwave infrared channels. And here we're using those two near IR bands, the veggie band and the snow ice band. So here's an example from a couple days ago. This was on the 18th, and just looking at the two input bands during the day. You can see that on the left we have band 3. That's our veggie band, and without doing any kind of animation, right? It's really hard to tell. Well, where do you have clouds? Where do you have snow? Where do you have ice or snow-covered ice? But when we look over this image on the right here, you can see the ice on the lakes shows up in a really dark gray, so a lot, much lower reflectance in that snow ice band. So that's why these two channels have been chosen to be utilized in this algorithm. And then, so what if it's nighttime? Then it just simply uses the skin temperature from GOES-R. So still, again, if it's clear and it can get the skin temperature, anything less than 275 K over the water areas is going to be considered for the ice. And then from there, it has to calculate the concentration. And I'm not an expert here, but just kind of wanted to try to put the pieces together on how these products are developed. So it goes through this tie points algorithm, which is basically looking at how much reflectance it's getting back versus the reflectance that you would expect for water and ice, and then calculating these probability density functions. So back to Lake Winnipeg and Lake Manitoba. This is from a little bit earlier on the 18th. This is the 15Z, and you should note these products are every 3 hours. So it's not, it's not a 5 or 10-minute resolution. These are coming in every 3 hours. So there's a lot of sampling that's going into each product. And you can see on the left here, our ice concentration. It did pick up a lot of ice on Lake Winnipeg and parts of Manitoba. I assume that there was probably cloud cover moving through there, and that's why we don't see a detection on the southern part of the lake. And then we can also look at there's an ice mask product. So this is telling us that it was a night ice detection. And then so ice surface temperatures, that is using the ABI bands 14 and 15. So that clean window that doesn't have a lot of water absorption, and then the dirty window that has some water absorption to it, and plugging into an equation, and depending on the clean window temperature that's coming back, it picks coefficients from this lookup table here. And here's an example of what the ice surface temperature product looked like for this case. You can see it's right around, this would be -20. So right around -20, which is pretty reasonable. It has been a lot colder up in Canada. Just that cold air has not been making it down here very often. And I wanted to show an example a little bit closer to home. This is the western basin of Lake Superior. You've got the Apostle Islands in here, and the area I really wanted to focus on is in this white box. And when we're looking, at this ice concentration, there were a lot of detections, and that's actually something, good thing about doing the evaluation is looking, why is it showing ice here? Is it a true or false detection? It seems like maybe that, these are probably false detections here, but here, in this area looks very real. So this is Chequamegon Bay on Lake Superior, and you can see on our veggie band, you have a lot of reflectance over the bay. And then when we look at our snow ice band, it's a lot darker. Not quite as, a little bit more reflectance than what we're getting over the water, but still pretty dark. So it stands out really well. And so, well, why is that bay frozen? Chequamegon Bay is a lot shallower and protected than the rest of Lake Superior. So there's an island out there that really protects the area from the waves, and it's pretty shallow. So 15 to 20 feet, except for a deeper trench on the west end. And so how can this apply to lakeshore flooding? So again, when looking at the evaluation here and just thinking about, well, so we have these products, we'll figure out where they work well, their strengths and weaknesses, but how can we apply them? And we do have the polar orbiter products as well. So I don't think this is just a GOES-R thing. This is the GOES-R would be kind of supplemental with the when you do have those clear skies to get that higher temporal resolution. And so lakeshore flooding is a big deal right now for us, and relatively for our office, a big deal in the more recently than it used to be. So how could looking at the ice products, temperature, thickness, motion, and concentration, how could that help us understand the evolution of the ice formation and then the during breakup season? And could it help us enhance our messaging for DSS and in our lakeshore products? So where do we not have ice? And if we do have ice, is it going to be enough to protect the shoreline? So when we're issuing a lakeshore flood product, the things we're considering is the fetch and the wave heights, the duration. So storm surge plays a big part of it, and of course the high water levels make it a little easier to get that more damaging storm surge or impactful. And then of course I've got it in bold here because shoreline lake ice. If we have enough ice, you could prevent waves altogether, but you could also, at least have enough ice along the shoreline that could prevent erosion should we get a high wind and high wave event. So here's just a couple pictures that our office had of some different ice. So from the Marquette area, and you can see this picture on the left. So there, we've got really the widespread ice cover. So in that case, we could really probably shut down our thinking, as far as we're not going to probably need a lakeshore flood products anytime soon. But then this picture on the right, that's showing some shelf ice along the shore, which you can see it can be pretty thick, and it can prevent erosion. So I've only been in this office for a year, and again, the lakeshore flooding, and I'll show that in a minute, is kind of becoming a bigger deal in the more recent years. So again, I have more questions than answers, but question would be, well, how, can we detect any of this shelf ice and its properties, and how, and what happens when you get big waves coming into there? So briefly just show the Lake Michigan and Lake Superior water levels. On the left, we have Lake Superior, and this is from Glacial. And then on the right, we have Lake Michigan and Lake Huron. And you can see for Lake Superior, we did go through a time, back earlier in the 2000s where water levels were pretty low, below the looks like 100-year average, but recently they've been a lot higher. So the last couple of years have been trending up, and this is just showing the annual mean. It's not showing the seasonal oscillations, as well. And then Lake Michigan and Lake Huron are up 2 or 3 feet in the last few years. And so I just took a look at what little bit of a, I guess, a climatology on our Lakeshore flood products. And just going back to 2014, we didn't issue a lot. In fact, 2016, we didn't issue any. So the red is our advisories, and then blues are the warnings. So in 2017, and that was an October storm that had like 25-foot waves. So that one we did issue a warning for, but really, more recently, we're seeing that a big uptick in the warnings of just, total amount of products. In 2020, we issued 40 warnings and advisories total. And so how does that pan out, looking at monthly issuances? And you can see, October, November, we're getting into a really unstable season. So, that's prime time for getting some big waves. But then we have a minima in February and into March. And here's the ice cover from last year, from 2020. So we did have at least an increase in ice. Our peak is usually the beginning of March, and we kind of peaked here in February. So, that could have contributed to less products, but of course, with it so heavily weighted on 2020, there also just the amount of synoptic storms we had could be playing a role too. So the two examples I wanted to show here are recent examples from last season. So we've got an example from Thanksgiving in 2019 when we had significant lakeshore flooding and damage. And at that point, there was not any ice. And typically, late November, we don't have that ice buildup yet. And then one is from February when we were kind of peaking in that ice cover. And that's actually for our Lake Michigan shoreline. And in that, we did have some ice. So here's a picture, and actually all the pictures and for this case came from our lead forecaster, Don Rolfson, and he gets out around Marquette and does a great job at getting us some really nice pictures for our weather stories. So here is, this picture is actually after the storm. You can see this is our Lakeshore Boulevard is pretty torn up, and we'll see some more pictures of that in a minute here. And hopefully everyone can see this animation. I'll let it loop a few times, but this is just the RAP analysis, 850 millibar heights and winds, just showing that we had a fairly slow moving 850 millibar low. You'll see here track from Iowa up into the northern part of Wisconsin and kind of across the Mackinac Straits with a long duration period of 40 to 60 knot winds at 850 millibars. And this is the observed wave heights from Glacial, and these are modeled. We don't have any buoys out in the lake for our winter season. They're all pulled in October or early November. But you can see, Marquette's right here, and with that east-northeast flow, the waves really did build up. We've got a long period of 12-foot plus and even 16-foot waves that come into the shoreline. And so here's a picture from the other direction, and you can see that the Lakeshore Boulevard is pretty much, it's gone. Some pieces of the road left behind, And someone, I guess, got cute with some rocks there to make a smiley face. And there's just a picture of some of the flooding from some of the storm surge that came in. And this also just kind of highlights how much water is coming in here. This is a break wall and then a marker, and there's still break wall that connects to that marker. And in most of, through all these images here, that break wall is pretty much under the water. And so the cost to the community of Marquette, they had already done about $100,000 in recent repairs to try to protect the road, and those were wiped out. I mean, with this storm, and it led to a $12.3 million project to move Lakeshore Boulevard 300 feet inland and raise it 4 to 6 feet, along with the multi-use path. And you can see that this is where the road was. So the Google Earth imagery hasn't been updated yet, but the road is now plotted in the right place. And here's our February 15th example, and this is when we did have some ice. And this was a lakeshore flood warning on our Lake Michigan side. And the thing to really notice here in the text is, we mentioned, in addition to the flooding and the waves, that there may be loose ice near the shoreline that could get pushed on shore, potentially causing additional concerns. This isn't actually something that we don't know what happened with this. That's another big challenge. But also, from the forecaster's perspective, really trying to understand, what is going to happen with the ice when the waves come in. It's pretty challenging. And it is back to that RAP analysis, and I put a star in the area we're looking at, and you can see we've got a trough coming through and some really good, strong southwest 850 millibar flow of 50 or more knots. This is from the National Ice Center. These plots are created for the Coast Guard, and I believe that this is from the polar orbiters, and this is updated twice a week, I believe. And so our area interest here with that southwest flow coming up the lake, generating a really long fetch in large waves. There's only 1 to 3/10 of ice coverage in that area. And let me just hop back here. Other thing to note, Green Bay is frozen over, so that's great. So southwest winds, we don't have to worry about lakeshore flooding on Green Bay for this event. And so here's the Galera observed wave heights, and you can see generally 6 to 8 feet coming into the northern shore here of Lake Michigan. And for this one, I don't have any pictures. I just more to highlight the challenge of lakeshore flooding and how ice can help, and how ice can also be challenging in understanding what's going to happen with it. And finally, one last thing, I mentioned the breakup in spring. So 2014 was a big ice year for the Great Lakes, and this is late April 29th, and I've got circled here the Keweenaw Peninsula, and you can see there's still a lot of ice out over Lake Superior. And this generated ice shoves, and even down along our Green Bay areas, we had ice shoves. But these pictures show, you've got a well that looks like it's in danger of being damaged, and ice is pushed up all around the structure. I believe it's a house on the Keweenaw Peninsula here. And so again, I know that there's not really a lot of conclusions here, more raising questions than answers. But at this time, I'll turn it over to Karen.
Great, thanks, Nick. Great presentation. We are asking if anybody has any questions, that you can put your questions into the chat and we'll read them off to Nick. And we are towards the end of our time, and I think I do want to send it over to to Jordan first before we get into the questions. If anybody wants to move on, if the time is ending for them.
Sure. Thank you, Karen, and thank you, Nick, for your great presentation. We will just wrap it up, but we'll stay on for questions after the formal wrap up if there are additional questions that come in, and I do have a few. But if you can't stay any longer, which we completely understand, please feel free to complete our feedback survey when you get a chance. And also, next week, we will have YJ Now, a research scientist from Sierra, to discuss the development of the satellite cloud vertical structure products for aviation users. As usual, Kashad and Lee will get an email out on that if you're able to join us. I will now turn it back over to Karen for the discussion. And I've got a few questions for Nick. Yeah, if you have to take off, we will see you next week.
All right, thanks. So we do have a few questions here. Looks like we have, just kind of go through here and make sure we get questions and not comments. So we do have here a question from John that says, do you perform any visual shore ice surveys during winter or early spring, given the frequent lack of clear and sunny days in the winter?
Yeah, that's a great question, and we do, we do have some webcams that we can reference, but overall, no. I mean, we don't. Not that I'm aware of, have any official way of getting any of these observations. And a lot of times, our understanding of the ice can just come from what we're seeing when we're out and about in the area. But that would be great, and especially when you get into like new ice and kind of that gray ice too, to see, well, how is that showing up, or if it is being detected.
All right, great answer. So we got another question here from Scott. Is the horizontal resolution of the ice product the same as the band 3 and band 5, the 1 kilometer nadar? The product looked more pixelated than that.
I believe the product, it is under the full disc. So I think it is the full disc that's being used for that product, but I'm not 100% sure there. So I can find out. That's a good question.
All right. We do have a quick comment here from Jeff. He said, nice presentation, Nick. He appreciates your comment about knowing that there may be some issues with the ice products, but you'll use them where they work best. And I'm not seeing any other questions right now, but we do have a couple that were presented or that were given here. How are you able to collaborate and evaluate these ice products when teleworking?
So that's actually been a pretty neat experience. We're using the AWIPS in the cloud. So Lee Byerl has been setting up cloud sessions, so then we can go in there and we can look at the current data. We can go back about 30 days, and it's actually really neat that you can get multiple people on there and kind of collaborating and talking about what you're seeing.
Nice, that's really cool. Again, if anybody has questions, just please put those in the chat and we'll read them off for Nick. We do have one more question here. Do you see any other potential applications in WFO operations?
Yeah, so we have talked about some other things, and one thing that can be a big problem here is blowing snow along our shorelines, especially when we get into lake effect and the colder temperatures. So you've got a really dry, powdery snow. But with that problem gets worse if you start getting some really good ice out over the water. So these roads are running right along the shoreline, and then you get a decent fetch for that blowing snow to get picked up and blown on shore. So I think that could be somewhere else that we can. It's not that we haven't had the ice products, I guess, with the the polar orbiters in the past. It's just, you know, how can we keep using this data and thinking about it? So it would be neat to look at, you know, past blowing snow cases and just see what the ice cover was like.
All right. So Jeff has another comment here. He says, we have a GOES-R provisional review for these ice products 30 minutes from now. So there's a little punk there for that. Jordan has a few questions. All right. Go ahead and join us in there.
Yeah, thanks, Karen, and thanks, Nick. So great summary of the lakeshore flooding aspects and the ice climatology. Could you talk a little bit about your decision support services when it comes to mariners and with the changing amounts of ice over the winter time? Are you seeing more shipping continuing during the winter months, and what kind of IDSS are you doing for those activities?
Yeah, so I've been here for about a year. I might not have the best answer here, but I mean, one thing I can't say, when they close the locks down, you know, our shipping season is dependent on the locks. So once they shut the locks down, our shipping season really you know, shuts off. So, you know, now, you know, we still issue the open waters forecast, and we still put out our gales, or, you know, our products for the open waters, but we don't really have any shipping going on until spring. And once they open the locks, then they will get out there with the icebreakers and start breaking that ice. So I mean, I know that for the Coast Guard, these ice products are important. And you know, as far as any direct DSS, that I'd have to talk to our WCM a little bit more about to see what we've been doing in the past.
And then on the topic of breakup, when you we're giving, you know, this GOES-R a set of cryosphere products, there's concentration, there's ice motion. Do you have the resources you need to kind of anticipate breakup? Do you feel like, I mean, it's one thing to know that ice is there, but I think the service that we're trying to provide from the Weather Service is, you know, when that breakup is going to occur. And I suppose looking at the synoptic situation, that can help inform that. But to some extent, does the ice state play into what the impacts are on the shoreline?
I mean, certainly, I think we have opportunities to use these products to learn more. Yeah, and about you know, we don't get those, that example of the ice shove. That doesn't always happen, you know. So, you know, even like looking back, well, when does that happen? That would be an interesting year to go back and look at in 2014 when we had those big ice shoves. And I don't, you know, I know some of the other offices might, you know, I don't want to speak for everyone. You know, Cleveland does a lot of the ice products, so you know, they might have a better understanding, you know, of what's happening in the breakup season.
And then my final question is, what kind of services do you provide for recreational fishermen that may be, you know, going out near the shoreline, and the safety of that?
Yeah, so that, you know, we put out ice safety messaging that will relay, particularly, you know, from the DNR, will relay the ice safety, and really just knowing, you know, ice is never 100% safe. But we haven't really gotten to the area of, you know, really, you know, safety messaging for current ice conditions. You know, we will, you know, kind of give the heads up. Well, so like this season, it's been warm. We've already had some incidents, and you might have to keep reminding people, but we're not actually putting out a forecast for, you know, what people can expect for ice conditions with recreation. And interesting you bring that up. When I was looking at that ice that we had on, in my example on Chequamegon Bay, I went to some of the bait and tackle shop websites just to see what they were reporting, and at that time they were saying, yeah, you know, there's 6 to 8 inches of ice, but there's a lot of problem spots right now. And then the northern end of Green Bay right now, we got people out there, and we've got the Big Bay Denock and Little Bay Denock on the north side of the bay. That's a little more, can be a little more protected. They're a lot more shallower. They've iced up, but you have a lot of open water right next to it, and you've got shanties out there that really aren't that far from the open water. So
Okay.
certainly something to think about in the future.
Thanks, and I guess Karen, I'll send it back over to you. Looks like we might have 1 or 2 more questions.
Yeah, we do have a couple questions here. So we've got from, and I know I'm going to butcher this name, but Sanmi or Sanmi. He says, have you ever used the, and I'm going to actually say this out, is the visible infrared imaging radiometer suite, the ABI flood product for the Lakeshore flood validation?
No, we have not.
All righty.
So that actually sounds really interesting.
All righty, well, sounds like something to look up in the future. So we have another comment here from Joseph. Says that GOES our ice products are made from FD, a 2-kilometer horizontal resolution. And we have a question from Scott. He says he thinks that it's very interesting that it would be compared to your 2014 ice show to one that happened just south of Buffalo, New York, that happened maybe 2 or 3 years ago.
Yeah, it would be really neat to see, to look back at those cases for sure.
All righty, any other questions? I don't see any right now. If anybody has another question, just throw it into the chat and we can get to it. We do have a few more minutes left to answer some questions here.
And I don't remember who you said asked the question, but if they're still on and they want to shoot me an email, the question about using the Lakeshore flood products from the satellite, if they can send me an email with that information, that'd be great.
All righty, I'm still not seeing any other questions, so I think if there's no other questions, I can send it back over to Jordan.
All right, thanks, Karen, and thanks, Nick. Great presentation. I always like to hear about some of the challenges on the Great Lakes. I grew up in Kenosha, which is, of course, on Lake Michigan, so spent a lot of time thinking about those impacts. That's all we have for today, of course. Next week, Thursday, January 28th, as I mentioned, YJ No from Sierra is going to talk about cloud vertical structure product for aviation users. So I hope you'll join us for that. And also, please feel free to get in touch with our great TOWR-S team if you have any questions about getting products in AWIPS that can help your operations. That team is willing to support as needed, so don't hesitate to reach out to them. So until next week, please stay well, and we'll catch you then. Take care, everybody.